Okay, so this is lesson 4-3 practice, and this should go pretty quick. Number 15, the graph of g of x is the graph of f of x equals absolute value of x, but it's translated 6 units to the right. Write the equation of g of x. So if we are translating to the right or left, that's the inside. So g of x is equal to the absolute value of x, and it's always the opposite for horizontal. And since I'm going right 6, I'm going to subtract 6, since it's always the opposite. And there you go. G of x is equal to the absolute value of x minus 6. Describe the graph of h of x is equal to negative 5x as one or more transformations of the graph of f of x is equal to the absolute value of x. Well, we've got really two different things here. This negative is going to flip it vertically. And the 5 is going to stretch it vertically. So let's go ahead and write those down. So first of all, we have a vertical flip, and you could say instead of vertical flip, to be more formal, because I say horizontal inside, vertical outside, so I say vertical flip on the outside. But to be formal, I'm going to say reflected over x-axis. And the 5 means it's vertically stretched by 5, by a factor of 5. So vertical stretch by 5. Okay. What are the domain and range of f of x is equal to the absolute value of x plus 4 minus 1. So basically this thing is going to go to the left 4 and it's going to go down 1. So if I just did a real quick sketch of this thing, it's going to go all the way to the left 4. 1, 2, 3, 4. 1, 2, 3, 4 if I could count. And then down 1. And it's going to kind of go up like that. Not really important to be accurate here. The important piece is that the range horizontally, this is going to go forever left, forever right. So the range is going to be all reals. The domain is going to be all reals. The range and vertically, well, we have nothing down here. Okay, so we start at -1 and we go up to positive infinity for the range. All right, so let's undo all of that. And let's write that down. We'll say domain is going to be all real numbers. You could write it like that, or you could write it as an interval from -infinity to positive infinity. Either way is fine. And then the range is going to go from -1 up to positive infinity, like that. Okay. And next up, graph each transformation from the parent function. So I'm going to probably do these in all different colors. So I'll put this one as blue. And so let's go ahead and I'm just going to put number 18 here. And none of these are too drastic as far as changes go. -3, right 4, left 4. Yeah, so this is not too bad. All right, so let's go right in the middle here. Like that, and we'll go here, and that should be pretty much okay. Not the best, but we're kind of going to be on the edges of this a little bit, but that's okay. So x and y, and so this first one is going to go right 4 and up 2, so 1, 2, 3, 4 and up 2, and it's just after that it's just our regular absolute value. Okay. Next up, let's do a purple for B, and let's go ahead, and this one is going to go down 3, and it's a vertical. Well, the inside you would say horizontal, but the 2 can be pulled out because it's just a positive 2, right? So you could either say it's a vertical stretch, okay, if you pulled out the 2, vertical stretch by 2. If you left it inside, remember it's always the opposite on the inside, so you could say instead of a vertical stretch, you could say it's a horizontal shrink. I prefer to say vertical stretch, but either way, doesn't make a difference. It is the same. So I'm going to go down 3, okay, and instead of going out like this, okay, it is going to stretch up by a factor of 2. So instead of going here, it's going to go right here, and then here, and then here, And same thing in the opposite direction. And so it's going to look like, whoops, that's not very good. It's going to look like that. And again, so, you know, like I said, I tend to think of things vertically for absolute value functions. So vertically, this thing got stretched. But it's the same thing as on the inside saying horizontally, it got shrunk, like we squeezed it in from the left and the right. But that is identical. Anyway, all right, next up here, let's go for this guy. So this one's got a lot of change. It's going to go up 3. Okay, so 1, 2, 3. It's going to go left 4. 1, 2, 3, 4. There's our vertex. But it's also going to be vertically flipped, or flipped over the x-axis, but it's just going downwards. All right, so there we go, just like that. And we'll have this thing go all the way through. Okay. And again, it's kind of hard to say it's reflected over the x-axis. That's another reason why I don't like that terminology, because if you do the other transformations first, then it's like, okay, well, I'm up here, like, let me use a different color, like this, for example. All right, but if I'm flipped over the x-axis, then you might say, well, this is going to go all the way down to here, so it's going to look like that, right, to be flipped over the x-axis. But that's not the case. You always do the reflecting first. All right, so that's kind of why I like to say it's vertically flipped. Some people might argue with that, but I don't know. I think it's accurate no matter what you do. All right. Okay. And we've got some sirens going on outside. I apologize for that. But for D, we've got a bunch of transformations going on here as well. We are going up 4, so 1, 2, 3, 4. We are going left 2, so 1, 2. So we have our vertex here. We are vertically flipped from the negative, and we're also multiplying by a factor of 3. So instead of going right to here, we're going to go by a factor of 3, so all the way down here. So from here, right, from 1, and instead of 1, multiplying by 3, so going by a factor of 3. All right, and 2, instead of going over 2, it would be 2 times 3, which is 6. So all the way down here and all the way down here. As you can see, this looks pretty complicated, but once you know your all your transformations, it's very easy to do. Okay, number 19, write the equation for each transformation of the absolute value function. So let me get my blue back here. Translate left 9 units, stretch vertically by a factor of 5, and translate down 23 units. So we'll say f of x. And yeah, I don't know, maybe I should give it a different name, right? Because this is f of x. Let's just call it L of x. There we go. We hardly ever use L. That's why we usually italicize it. So you can tell it's an L instead of a 1. But anyway, L of x, we'll say, is equal to, we are stretching vertically by 5 times the absolute value of x. We're going left 9, so plus 9. Remember, it's always the opposite. And we're going down, horizontal is opposite, I should say. We're going down 23, which is the same, so minus 23. Okay. Next up here, we're going left 12, stretch horizontally by a factor of 4. Okay, so this one is horizontally, okay? So remember that when you say stretch horizontally, okay, that is the opposite. Horizontal is always opposites, okay? So actually, you'd be vertically stretching it by a factor of 1/4. The opposite of 4 would be 1/4 in this case, okay? So I'll show you how to write that in a second. And we're reflecting over the x-axis. Okay, so it's going to be negative in front. So let's call this one m of x, I guess, to continue on from L. And so let's see here, we're reflecting over the x-axis, so this is equal to a negative number. And I am going to, they're saying horizontally by a factor of 4. So we could just put, I'm trying to think, can we put that 4 on the inside? Horizontally by a factor of 4. That is going to be the opposite, which is 1/4. Let me just think about that for a second. I know for sure it's going to be 1/4 on the outside if we write it like that. I'm just trying to think in my head how we would want to write it the other way, but whatever. Okay, so, and we have, let's see, we're going left 12 units, so that would be x plus 12. Remember the opposite for horizontal. And let's see here. Is it going up at all or down? Doesn't look like it. So this guy right here is going to be our answer. There is actually another way to write this if you distribute that 1/4 inside of here, but then that's going to change things up on the inside, which I would not recommend doing, and that is why I prefer to think of these things in vertical terms. When I say horizontally stretched by a factor of 4, that means vertically stretched, okay, by the opposite of that, which would be 1/4, okay? All right, anyway, and then let's go to our last one, C, which is, we got a bunch of different changes here. So first of all, we are going down by 4. We are going right 2, and we are stretching by a factor of 3, it looks like, okay? So let's go ahead and write that. So this would be n of x is equal to, and this one is a vertical stretch by a factor of 3 times the absolute value of x. I'm going right 2, so x minus 2, the opposite. And I'm going down 4, so minus 4. Okay? And that looks like we are all, that looks like that's the last one here. So let me zoom out, scroll up, so you guys can see everything at once. And that is lesson 4-3, practice questions.